பொருளகத்தின் பொன்வணக்கம். பொருளகத்தின் பொன்வணக்கம். விழியத்தை பாருங்கள், நுட்பத்தை நுகருங்கள். பொருளகத்தின் பொன்வணக்கம். பொருளகத்தின் பொன்வணக்கம்.
First thing that I would like you all to at least think about, like what exactly has happened that because of that we are talking about data science. So although the data science is a kind of old concept, but the practical implementation or practical usage or application of data science we started seeing in past, let's say 10 to 15 years. There weren't any data science, at least in India, there weren't any data science opportunities in last 15 years, right? Mostly people were more interested towards software engineering and software engineer roles. And those people were, only those people were interested in software engineering role who comes from the software background, maybe computer science or information technology background. And even if non-technical people who would like to get into software engineering role, it would take a lot of effort for that person to get into this domain. But data science is kind of different. Although it looks like the data science comes from the computer, it's derived from the computer science background. But I'll tell you the recent statistics and everything, and you will realize it. It's not the case that data science, only people who are coming from tech background can become data scientists or get into data science domain. That is not the case. Majority of the people who are getting into the data science are those people who are into non-tech background. And there is a reason for that. We'll talk about those reasons in later slides. But again, getting back to the question, why are we even talking about data science in this particular era? What has changed? So it's not the case that data science is very new. The concepts or the key ideas of data science that you will see when you get into the data science are very old. It's like more than 50, or maybe some of them are like more than 100 years. The key algorithms or key mathematical intuitions are also very, very old. But something has changed because of that. We started talking a lot about data science. So there are two aspects of it. The first thing is the growth of data. So like before 20 years or 25 years, we didn't have a lot of exposure to the internet, right? Internet was very, very new. Like it's only 25 years when internet started, to be honest. And it was very new. And but recently we started in after early 2000, the internet expanded a lot. People started having access to the internet. And because of that, we had access to a lot of repository, a lot of portals where people can contribute a lot of knowledge, and a lot of websites, a lot of information, a lot of applications. So many things started happening. And because of that, we started getting a lot of data. This was the first thing, the data. And because of it, because you have a lot of information, right, you can do a lot of things with these information, right? People started using these information to do something extraordinary, to maybe predict something, to maybe analyze what has happened in past history, and based on it, what we can learn. Because with history, you can learn a lot of things in general, right? So because of that, data has started increasing. And now in this particular era, data is increasing in exponential, right? And because of that, because the data is increasing exponentially, the use cases related to data set is also increasing exponentially. That's why you're seeing a lot of startups, not just in India and all around the world. And again, because of that, there is a requirement for a lot of workforce who can understand the data and do something extraordinary. But unfortunately, the growth by which the people who know data science or who can do something extraordinary with data is not, the growth is not as similar to the growth of opportunities that we have. Okay. So there is a shortage, a huge shortage, to be honest. And to fill this shortage, we have a lot of data science opportunities, right? So it's like there is a catalyst, but we are not able to fill the catalyst because many people claim that they are data scientists, but actually who understand the data and who are skilled, they are very few. Okay, so that's the first point. Because of it, there is a huge, you will see popularity of data science opportunities, right? The second thing, which is the most important thing, the reason we started getting more data science related applications or use cases is because, again, in the second thing, two things changed. One is we started having a lot of a very powerful powerful computers, right? Before like 15 to 20 years, we didn't have powerful computers. We have single processor, and those can do very simpler tasks, single tasks at a time, sequential tasks. But now we have like multi-processors, and we have GPUs. We have started utilizing GPUs to do something extraordinary, parallel processing. So hardware has increased, the quality of hardware and the amount of data it can process has increased tremendously. So because of it, now we can do something extraordinary. That's the first thing. The second thing is the software has changed. The quality of software through which we can do something extraordinary has changed. We have programming languages. Programming languages like C, C++, Python, they were very old, but now they became so good. For example, Python, it became so good that it has so many powerful open source libraries. Like you don't have to write anything from the scratch. Rather than, there are many powerful libraries like TensorFlow, PyTorch, through which a very complex task you can achieve in a single line of code. So this made the life of a researcher or data scientist very, very easy. So the only thing that you have to understand, to be honest, is the intuition for data. You should be able to meditate on data, and then you should be able to kind of tell that what are the things you can do. If you're ready to ask the right question, then you are already a data scientist. Now, other things are only a set of skills which anyone can learn, to be honest. You just have to be a sincere person, and you just have to be persistent with this. You just have to have a very strong willpower, and then you can become data scientist, irrespective of where are you coming from, right? Now let's get to the right question, like what exactly is data science? And I'm not going to answer this question with any kind of definition or anything. Rather than, I will try to give you some example, a very basic example, and try to motivate you for what exactly data science is with this example. So before even I go to that, there was a famous professor from Stanford who said that data science is a new term, but in the same way, Columbus discovered the new continent 500 years ago. Now, this is a metaphorical statement, but with this, his intent was that, right, Columbus discovered America. So it's not the case that Columbus went and he invented America. America was already there. I mean, the land was already there. Like there were native Indians who were already living there. There was a civilization already thriving. It's just that he was able to find that, right? Those people were able to find that, but it was already there. Right. So same way, it's not the case that we have invented data science now, like in last 10 to 15 years. All the concepts that you see in data science, or you will be seeing in data science, are very, very old, has been designed many, many years ago. People have used it theoretically, at least, or very small amount of data to show it that actually it works. Then now what we have a lot of data, we have a lot of processing power. So now we can see the practical usage of such examples. So that's the only thing that has changed. Otherwise, most of the places when you get into the actual learning part of data science, you see many concepts which are very, very old. So sometimes you will see hundreds of years of old, right? But now using those basic algorithm or old algorithms with new data and new processing power, you can do something very, very extraordinary. Okay. And in the same case, I'll take a similar examples, right? So what was the idea, how we came up to this particular series of events is like when we were at the inception of civilization, I would say. Mostly whatever we saw, we observed, based on it, we decided that something is happening, right? So mostly empirical analysis we used to do. We didn't have enough tools or anything to actually prove anything. Rather than whatever we saw, based on our observation, we used to declare, or we used to state that, okay, this is something like this happening. Okay. And after a few years, when civilization became more strong, Then people started giving the axioms. They have become the theoretical analysis. Then people started speaking about generalization, that okay, something like this is happening, and if in the next time also something like this looks like something like this is happening, then this will happen definitely. So this is known as theoretical analysis and theoretical proofs. So people started giving generalized form of many things, right? In last 50 years, we started seeing that more empirical computational analysis started happening. We had computers, so we can actually look into the data. We can actually compute something and then can say that okay, this will happen. Okay, so for example, we using theoretical analysis, we know that what is the distance between Earth to Moon. It was a very theoretical analysis. We didn't have any way to show it or prove it. Now, once computer came, we started using the data of sending the light and then using the angles, and based on the computational analysis, because computer could process a lot of information. We could actually practically confirm it that okay, this is true. This is the actual distance, or this is what you will be seeing, right? And in last 20 years, we started using this data to do something extraordinary, right? Now we can predict something. Given the past history, you might predict something, you can classify something, or you can generate something also, right? So this is the series of events through which we came to this place where we are. I mean, it's not like we just invented data science right now. There are series of events, hundreds of thousands of years before, through which this series of events we were able to come to this point where we are able to do something extraordinary. Yeah. I'll share the slides so that if you want, you can. Although, anyways, I guess you will be getting recording and other things. Okay, now I'll take an example. Okay, very basic example I'll take. You all will be able to relate with this example and understand it. The idea with this example is to just motivate you to a very simple single idea, and then just to show it that similar kind of ideas can be used to do something extraordinary. That's all data science is. So I'll play a very small video, and just twice I will play. It's a very like 4 or 5 seconds video. I just want you all to focus on what exactly is going on, because I'm going to ask a question on it. Okay, so I'm going to play it right now. Okay, so I said that it was a very small video. Let me play it one more time so that again you can see. Just watch very closely what is happening. That's all you have to know. Okay, so I'll give you the context, what exactly I'm trying to tell here. So you saw that there is an army, and then they are trying to breach a wall. It's a castle, and they're trying to breach the castle, get inside the castle. So for that they have some ladders, right? And they're using these ladders to climb the wall. Okay. Now you think about this. Okay, this was a very famous movie. I hope you people can guess. Okay, what movie is from which movie this? Or anyways, it's written here. So, anyways, the idea is that the people who are trying to capture the castle, they have ladders, and then they're trying to use this ladder to climb the wall. Now, the interesting part that I want you to understand here is this is like these kind of wars where swords and those things javelin were used. People didn't have the access to a lot of information, right? And one of these information is, how do they know that what should be the height of the wall? So how did they create the ladder? Ladder could be short. Ladder could be very tall also. A very tall ladder is also not good. But mostly you will see in wars, and it's a very interesting question. How do they know that what should be the height of the ladder, right? So this was an actual problem that usually during the war people have faced, right? And a very, very simple idea they used to solve this. Empirically, they just saw. There was no theoretical proof to back it up. But even in using empirical analysis, they were able to show that this actually works. And people used to win war because of this simple idea. I'll show you the simple idea, right? So that's what, again, it's a real story which I'm speaking, not that particular video, but in general they are real story. People used to strategies use a kind of collective intelligence. It's a concept within data science to plan attacks, and you can read the Thucydides studies on war, where he has said that how Romans used to do that. Okay, so I'll give you a very simplistic view of the problem statement. Okay. So the problem statement is, I have a castle and then it is protected by a very thick and a very tall wall. You don't know what is the height of the wall, right? And you being, let's say, a general chief of another kingdom, and then you want to attack this particular castle. Your first task is to breach the wall. Get inside the wall, right? Again, it's just put yourself in the shoes of people who were like thousands years before, right? Because it wasn't easy to just break the wall, or because it will take a lot of time, lot of effort, lot of time. You didn't have nuclear bombs or something like that to just annihilate everything, right? And again, the other thing that you don't know the height of the wall, and one more thing, that height of the wall is not always consistent, because these are very secretive things. Height of the wall, thickness of the wall, how they have created, these are very secretive things. Only few people had the access of these things, and the height of the wall is not always consistent. They made it like this so that you should not be able to judge how to climb and everything, right? So what strategies used to do is, it was a very simple idea. They will send many people, which are spies, close enough to the wall so that they can count the number of marbles vertically. Okay, so their job was just to count the number of marbles like this vertically. So they'll send someone, and they'll send one more person. They'll send like hundreds of people like this. Everyone will go at a point, at a place where they will see that, okay, this is the right strategy. This is where we should, from this place we should attack. People will go, and then they will just count the number of marbles. They were using marbles only. Vertically, right? That's all they had to do. Okay, and they will come back with the count. So first person said that, okay, X is the number of marbles I counted. Second person said Y is the number of marble. Third person will say Z is the number of marble, right? They all will say some number because they have counted something. Now what they will do, the general will take all the numbers from everyone and then just take the average of it. Okay, so if I have some n numbers, so I'll take the sum of these n numbers and divide it by n, and that's the average, right? And that will give me the average count. So it's just an average count that I am having vertically. Now the second task is to find the thickness of the marble. Usually it was very easy because very standard marbles were being used. So people will know what is the size or height of a particular marble. So using those height, people were able to approximate that, okay, by using the average count, number of marbles, and the thickness of each marble, this should be the height of the wall. And then they used to create ladders or build ladders based on this information. Very empirical, okay. But always it was the case that whatever ladders they built, it was almost accurate, okay, almost very precise to the height of the wall. And with this, they were able to use the ladders to climb the wall and get inside, to breach it, okay. Now the concept was, it wasn't proven, there was no theoretical evidence for this, but the concept was that if everyone is contributing and everyone is intelligently doing something, and if I take all the information and kind of accumulate it using a statistics. So the statistics that they used here is a mean. Okay, if you use this statistics, then you will be able to get to a very, very precise answer. And this particular concept you will learn in statistics if you get into the data science part. This is known as central limit theorem, but you don't worry about it right now. But they also didn't know. They just empirically saw it that, okay, something like this is working. They should try it, and they tried, and every time it was working. And this is how they used to do. For thousands of years they did. Okay, let's go this was like thousands of years before. Let's go a few hundreds years ago. So there was a famous scientist or statistician whose name was Galton. So what Galton did, he proposed a competition in a fair. Okay, so the competition was that he had an ox, and he asked all the participants of this competition to guess the weight of this ox. They cannot touch the ox, they cannot weigh the ox, of course, they cannot do anything. They just have to observe the ox, and based on their observation they have to tell the weight of the ox. Okay, and again the winning strategy was the winning rule was that the person whose guess is closest to the actual weight of the ox will win the prize. Some prize was there. Now what the experiment that he did, everyone guessed something because everyone wanted to participate. For them it was a gamble. So everyone observed and tried their best to guess the weight. Everyone gave some that it should be this much kg, this much kg, this much kg. Hundreds of people participated. Again, he took the same idea, very simplistic idea. He took all the numbers, all the guesses that everyone did, took those guesses, took the mean of these guesses, and then came up with a number. Again, fortunately, it was the case that the number that he came up with, the average, which is the average guesses, was very, very close to the actual weight. Not just very close, the error margin was only 5%. Okay, and it's not the case that it only happened once. Every time he repeated the experiment many times for many fairs, and every time it was the case. And in eventually he proved it that if similar kind of statistics you use, where multiple people are using their intelligence collectively, and if you are able to aggregate it in a proper way, then you will get the right answer. Now this started, and with this simplistic idea of taking the mean of guesses. Okay, he was able to show that you can actually solve very, very complex problems using simple statistics from and simple contribution from each person. Now, if you see in this particular experiment, every person contributed very less. Every person had to use very small level of effort, right? Or you just had to guess, observe and guess. But you were able to solve a very high problem, a very, very complicated problem to find the weight of an ox. So complicated that actually this kind of competition was still taking place in many fairs, and what people started doing is they stopped using the actual weighing machine to weight the ox. They will just declare the competition, take the average, and whatever is the average, they will just say that, declare that this average is the actual weight, and person whose guess was closest to the average will win. Because they wanted to save the cost of this weighing machine, because weighing machine is also very big to weight an ox, right? So the point is that people were able to, this was a very complex problem, right? And he was able to solve this complex problem. He was able to show also theoretically that such kind of complex problems can be solved using a very simple statistics to do something extraordinary. Okay, and this is I'm just taking a single thread. Okay, there are so many such use cases, so many extraordinary use cases, which comes from a very simple idea and then spans out to something very, very extraordinary. All the things that you will see in data science, whether it is statistical modeling or machine learning or data analysis or deep learning, you will see that the actual idea is very simple, very basic, very simple, but you are just spanning it to a very a large number of things or a large number of parallel processing, and because of that you are able to do something extraordinary. Similar goes the idea for the neural networks. Every neuron does a very simple task, very, very simple task. Okay, but you have a lot of neurons, and every neurons have some dependency on each other. Because of that, you are able to do something very, very extraordinary. For example, you see ChatGPT kind of thing, right? Okay. So getting back to our discussion, so this idea of taking the user contribution, small contribution of user, and aggregating the contribution of each user and doing something extraordinary. Now we in the current scenario, if I talk about, we have multiple application where we do this. There are so many direct applications, but indirect application, but I'll talk about direct application or direct portals where you will see. So I'll give you one example, which is the online portal that you guys are seeing. For example, one is Wikipedia and Stack Overflow. Okay. So Wikipedia, if I talk about, Wikipedia is one place where anyone can contribute. You can go there and you can start an article. No one cares who you are. You don't even have to register. You can just go start a blank article about something and start writing about it. Right. Stack Overflow also almost similar, but it has some restriction. But everyone is invited. You have to start and you have to comment first, and then after commenting, if you have some more score, you can start asking questions. After that, if you have more score, then you can start answering questions, and then there are so many others. But in the end, everyone is appreciated. Everyone can participate. You just have to learn few things. That's all. So the idea is again that everyone can contribute, and if you see, it's not the case that few people are contributing a lot. Many people are contributing, and everyone's contribution is very less. But because so many people are contributing, but very less, but because of aggregating all this contribution, you can have something extraordinary. For example, Wikipedia became so famous that there was hard copy of encyclopedias that we used to read when we were kids. It eradicated the whole concept of encyclopedia. No one reads encyclopedia right now, right? And the reason was all the encyclopedia was being written by like top people, Nobel Prize winners, even presidents were writing in encyclopedia, top researchers were writing. Only top people were had the privilege to write the content of encyclopedia, whereas Wikipedia anyone could write. Still, Wikipedia content was so good that it overshadowed the overall encyclopedia. Everyone has seen Wikipedia, or sometime at some point of time you might have read something in Wikipedia. Similar goes with the Stack Overflow. Stack Overflow contribution became so good or so famous that before Stack Overflow, every software, when it got released, it had a documentation. So if you have any problem with the software, you have to go to the documentation, read the documentation, and then come understand the error that you are getting. Otherwise, you will never know. So this was the case like before 2005, 2004, right? So imagine how struggling it was for a software developer to build something new. To go through the overall, like there was like 200 pages of documentation, and you just have to go through it and understand what exactly is going on, or you will never know what kind of error you are getting. Nowadays, it's not the case, right? If you have an error, you just search it, and mostly you will get the answer on Stack Overflow. You'll find that, okay, if you are getting similar kind of errors, this is what the answer is. Very easy. Our life is very easy because of such portals. That's the second thing. And the third thing is that these portals, because of these portals, you are able to do something extraordinary. So, for example, these speech to text or speech recognition applications like Alexa, Siri, they are using the data from Wikipedia and Stack Overflow and other open portal. Not just this, the newest enhancement, newest release, which is ChatGPT, GPT-4, or all the LLMs, they are being trained on such. The majority of the data that they are being trained on are from Wikipedia, Stack Overflow, and such open portals. And because of it, it became so good because it has all the knowledge from Wikipedia, right? So these things indirectly, which are being contributed by us only, we people, we have contributed very less, but because of this overall aggregation of the contribution, we are able to do something very extraordinary. We can see some applications which are like out of the blue. When ChatGPT came, we started seeing, okay, it can do almost everything. It can pass the exams. It can answer almost everything, right? And this comes from very past contributions, at least not 100, but at least past 10 years of contribution that we are having in these on the internet, right?
நாடிய சொந்தம் நான் காணும் பந்தம் எங்கும் பேரின்பம் நாளொரு வண்ணம் நாம் காணும் எண்ணம் ஆனந்தம் காற்றினில் எங்கும் என் அன்பு செல்ல ஏங்கும் என்னாலும் ஏக்கம் உள்ளாடும்